Hello students, welcome back. This is the 8th tutorial class on operating system, and this class will be presented by myself, Dr. Sudip Mandal, Assistant Professor in Department of Electronics and Communication Engineering from Jalpaiguri Government Engineering College. So coming to the content of this class, in this class we shall cover three important topics on operating system. Those are context switch, second one threads, and last one is the monitor. Okay, so these three important topics will be covered throughout this presentation. So let's move on. So the first topic is context switch. In the operating system, that it is possible that sometime we need to bring back the process which is already running into the waiting state. Consider an IO interrupt occurred. So whenever a running process want to perform some operation, then we need to move or we need to remove the process from the running state and put it back into the waiting state or block state. Okay, and then put the process into the IO queue. Okay, so we can switch between from running state to the wait or block state. Okay, so moreover, sometime it is possible that a process with highest or higher priority is coming into the ready state. So at that time, what will happen? The current running process will be moved to the wait or block state, and the process that is with higher priority will be executed. That means we need to switch between two process or two task. So that is nothing but the context switch. So a context switch is a process that involve switching of the CPU from one process or task to another, so through which we shift or switch between two processes or two tasks. That is nothing but the context switch. Okay, so what is the necessity of this context switching? Basically, it is one of the essential feature of the multitasking operating system. As we know, in case of multitasking operating system, different tasks are performed parallelly or different process are executed parallelly. Okay, so what you need to do that during the execution of these processes, we need to switch between this process, and this switching or this context switching are processed or executed so fast that it can give us an illusion to the user that all the processes are being executed at the same time. Okay, suppose there are p1, p2, p3, p4, p5, five processes are ready to be executed. So so what will happen? So initially, suppose for 1 microsecond one process is executed, and the next for next 1 microsecond next process, that is p2, is executed. It is quite similar to the time division multiplexing, where different signal are being sent by the transmitter at different time interval. Okay, so context switching, by using context switching we can switch between different processes, but the switching speed is very fast. Okay, and it is so fast that it can give us an illusion that all the processes are executed at the same time or parallelly, but in reality only one process or only one task is being executed at one particular instant of time by a processor. Okay, so that is the context switching. So when the context switching can occur? So first of all, as you already told, when a process with a high priority comes into the ready state, at that time the execution of the running process should be stopped and the higher priority process should be given to the CPU for the execution. And the second case, when an interruption occur, then the process in the running state should be stopped and the CPU should handle the interrupt before doing something else. Okay, so that is for in this for these two reasons, context switching can happen. And what is inside the context switching? A context is the content of a CPU register and program counter at the point in time. But so what is the necessity of this program counter at or the CPU register? Because whenever we switch between two processes, we need to store the current program counter of that process. or the others information related to the CPU. Okay, so we need to store them. So now coming to the steps for the context switching, you can see that there is two process, process P1 and process P2, and initially the process P1 is executing. So we are considering that at some time instant some interrupt or system call has been occurred or called. So at the same time, what will happen? It will store the current state of the process P1 into the program control block for the process P1 or PCB1. So all the necessary information associated with the P1 will be stored. Okay, and then what will happen? As process P2 is in ready state, what will happen? It will load the state from PCB2. All the information associated with the process P2 is stored in the PCB2, so it will reload the state from the PCB2. So during this interval, PCB2 or process 2 is in ideal state, whereas before the interrupt or system call, the process P1 is executing, but whenever there is interrupt, it going into the ideal state. So you can see that at up to reload state, reload by the CPU, the state of the process become ideal. Now after that, the process P2 is starting to be executed. Okay, now during this time, the process P2, the state of the process P2 is executing. Okay, now again, after the completion of the process P2, or after some interrupt again, so what will happen? So at that time, the current state of the PCB process 2 is stored into the PCB2 program control, sorry, process control block of the process 2. And next, what is stored into the PCB1, that is again reload or recalled. So reload the state from the PCB1. Again, we stored reload the current state of the PCB1 for the process P1, and after that, again process P1 will started to execute. Okay, so this is the step for context. You can see that here the state. Here you can see that at this time or during this interval, the program execution is switch between P1 and P2, and after that from P2 to P1 again. So at this interval, the state of the process P1 become ideal, and after that again it is started to execute. Okay, so this is the defined step for context switch. That means whenever there is context switching, the current state of the process will be stored in the PCB1, and then it will reload, it will load the process which is ready to be executed, or which have higher priority, or which is responsible for the interrupt. Okay, and after that time, that process will be executed, and after completion of that, again it will store the necessary information of that second process into the respective PCB, and after that it will again started to execute on the initial process. So this is the basic approach for the context switch. Here it is quite interesting to observe that up to this, process P1 is executed, and during the and when the process P2 is started to execute at this time instant, but in between them, when the same process is going on, actually CPU is doing nothing, because it is just saving the necessary information. Okay, CPU is doing nothing with respect to process execution. That means during this interval or this interval, the CPU is doing nothing with respect to process execution, but at the time they just try to store the necessary information in PCB. So basically this is the disadvantage of the context switching. Okay, so because it requires some finite amount of time for the context switching, and during that time it will save the necessary information into the process control block. Okay, so that the running state is move into the move into the ready state, or vice versa. Okay, so during that time there is no useful work done by the CPU from the user perspective. So that is the main disadvantages of context switching. Clear? So switching between two process is nothing but context switching. Now coming to the second topic, that is threads. Okay, So, what is the basic definition of threads? Before discussing that, before going to the conventional definition of threads, let's consider two examples. Suppose we are running a MS Word processor in our laptop or desktop. So, whenever we open MS Word processor application, so there we already know there are different dedicated function is associated with the MS Word, like uh, um, whenever we typing something, so at the time the CPU will try to read the keystroke from the user. Okay, and it will suppose and other thing like it will try to read the previous written word, and it will display the different graphics, animation or image. Okay, sometime moreover it will try to perform the spelling or grammar checking in the background section, and we can also able to save the file. That is the different task. And moreover we can change the alignment, border, page size, page number, date, like all these things can be done during the MS Word processor. So it MS Word processor application is a very huge task, a very huge job, but it has some dedicated functionalities and which can be done separately. Okay. Similarly, suppose consider web browser processor application. So whenever we open some Google Chrome, consider. So suppose you I try to search something in Google. So at the time we need to read the keystroke from the user, and after that whenever we click the search button, it will show the respective display image, show the respective image or text, and it can download the respective video, audio from the network. And moreover what will happen, whenever it will also check is there is any kind of network problem or not. Okay, and it will also check for the different kind of malicious virus, etc. That means web browser application is also a very huge application, but it has different dedicated functions. Okay, so all these different and dedicated functionalities of a process are considered as a thread. Okay, like some part of the processor, or some part of the MS Word processor has been dedicated to get the input from the keystroke. Okay, some part of the MS Word process is try to check the spelling error or grammatical error, etc., etc. So all this defined and dedicated functionality for a particular process are considered as a thread. Okay, now coming to the formal definition. Okay, so formal definition of thread is nothing but it is called as lightweight process. Okay, so process, it is a huge task or complicated process or heavyweight process, but thread can be considered as lightweight process, but that means its functionality is limited. That's why you call it as lightweight process. Okay, and we can call it as the basic unit of CPU utilization. So why do we need why do we call it a CPU utilization? By using or by defining different kind of thread, we can utilize the CPU maximally. Okay, because a different part of the process can perform different type of thread at the same time, or different type of function at the same time. Okay, so that's why I call it that the basic unit of CPU utilization. Okay, and each thread should have a thread ID, a program counter, a register set, and a stack. So all these information are necessary to perform or to work of a thread. Program counter is not to be stored for where the next program is to be fetched. Register set next it will use to store the necessary information, necessary input output, and a stack when the some program call is stored, that will in that case it will store the respective um memory information. Okay, so a thread is thread is nothing but a lightweight process. Okay, and it's here with moreover what it's here, it's here different code section, data section with other system resources. Okay, so it's here with the other thread belonging to the same process, its code section, data section, other operating system. Suppose in MS Word we are typing something. Okay, so at the same time what's same time the data which is input from the keypad, that will be stored that will be checked for the grammatical error, that will be checked for the either it is within the border or not, it will check for the respective alignment, it will check for either it is bold or italic in front. All this will be considered. So this same data will be shared among the different threads of the same process. So it's shared with the other thread belonging to the same process, its code section, data section, and other operating resources such as the open files, signals, etc. Okay. So now based on the uh, weight, or based on the thread, we can classify them into the two types: single thread and multiple thread. Okay. So a traditional or heavyweight process has a single thread of control. That means uh, it all the function will be executed by a single resource or single code section, data section. It will not be shared by the others. That means the dedicated functionality are not considered here. Okay. So that's why you call it as the heavyweight process. Okay. That's why but the traditional or single thread process is not suitable for the multitasking. Now if the process has been divided into multiple thread of control, okay, that means we can do more task at a certain amount of time. Okay. So that's why we can say that threads provide a way to improve application performance through the parallelism. But in case of single thread process, we can perform only one task. We cannot perform different tasks for the same process parallelly. Okay. So that's why multiple thread is preferable. So multiple thread of control is very efficient for us. So we can also say that threads represent a software approach to improve the performance of operating system. Here you can see that this one is the first one denote the single process, single thread, and this one is the multiple thread. You can see that this denote the code section, this denote the data and file section, and this denote the register counter and stack for the respective thread. So we can see that this is, as this one is the single thread, it will perform a single task. So this one is not suitable for multitasking but here you can say that but there are three thread here. So for each of the each thread can access same code or code for the data, code for the total process, and they can access data, they can access the all the others files also. And for the each of the thread there is dedicated separate register counter stack, register counter stack, register counter stack for each of the thread, and they can perform different functions separately, but they can access the same code section, data section, and file section uh, at the same time. Okay. So suppose consider the ms word. So whenever you modify, suppose each thread is the first thread is responsible for checking the grammatical error. So whenever there is a grammatical error, so it will correct it, and respective data will be modified. Then suppose the second thread is responsible for saving that data, auto save. So after that, modifying data by the single first thread, second thread will be save the respective data. So like this way. So this is the multiple thread, and which is very efficient. Okay. Now, again, I'm trying to say that context switching. I already told that earlier that this is the switching between two processes, but context switching is also valid for the switching between multiple thread also. That means switching between first thread to second thread to third thread. That is also that can be also called as context switching. Okay. So that's why I'm during the definition I'm mentioning that this is a switching between multiple process or two process or task. So here the task is denoted the thread. Okay. So the switching between threads are also can be considered as the context switching. So this one is the single what we can say, yeah, single thread, and this is the multiple thread. Okay. Now the difference between the threads and process. So obviously a process is a complicated way. So process can be called as the heavyweight or resource intensive, whereas thread is lightweight or taking lesser resources than a process. And whenever during the process switching that means during the switching between two process switching needs interaction with the operating system. That means you need to store all the information from the PCB1 and move to the respective waiting state or ideal state, and then started the others process execution. So that means operating system interaction is necessary. But during the thread switching, as all the threads are within the same process, so thread switching does not need interaction with the operating system. So because all the threads are remain within same process, and we are already executing one process, so inside the execution of the all the threads or task, we don't need any permission, or they don't need any kind of interact with the operating system. Okay. So next, third point, in multiple processing environment, each process execute the same code and but has its own memory and file resource in case of process. Whereas all threads can share the same set of open files, child process, data, etc, etc. Fourth part, if one process is blocked, then no other process can execute until the first process is unblocked. It is very important characteristics for process. While in case of thread, while one thread is blocked and waiting, it is possible that other second thread can perform the other's task also. Okay. Now fifth, multiple process without using threads are more use more resource. That means if there is no thread, that means if the multiple process with no thread, or sorry, with single thread, then we need to use more resource, because for each of the application, each of the task, we need to execute the process separately. Okay. So multiple process with using thread use more resources, while multiple threads process use are fewer resources. Okay. Six, in multiple process, each process operate independently of the others, and in case of thread, one thread can read, write, change another thread's data. This is the main difference between process and threads. Now types of thread. So threads can be implemented using in the following two way. One is called user level thread, and another is kernel level thread. As the name suggests, the user level thread are managed by the user, and kernel level thread, that means here operating system manage all the threads, okay, acting on kernel, which is what is kernel. Kernel is nothing but the core of the operating system. So user level thread and kernel level thread. So let's see the difference between these two type of threads. So user level thread are faster to create and manage, whereas in case of kernel level thread, it is very slower to create and manage. And to implement, second point is that to implement the user level thread, we need to create a thread library, or we need to design a thread library. Whereas in case of kernel level thread, operating system support the creation of kernel threads. Third point, user level thread is generic and can run on any operating system. Okay. Whereas kernel level thread is specific, and it is specific to the particular operating system. And fourth point, multi-threaded application cannot take advantage of multiprocessing, and kernel routine themselves can be multi-threaded. Kernel level are already multi-threaded. Clear? So these are the main difference between user level threads and kernel level thread. Now multi-threading model. So it is quite possible that some operating system provide a combined effort in between user level thread and kernel level thread facility. Okay. That means there is some kind of hybridization between user level thread and kernel level thread to get better efficiency. Like Solaris is a good example of this kind of approach. Okay. So in combined system, multiple thread within the same application can run in parallel on multiple processor. Okay. Now multi-threading models are basically three types. First one is the many to many relationship, second one many to one relationship, and third one is one to one relationship. So now let's see. Now this is the basically block diagram of many to many model. Here you can see that this is the user space where user level thread can be created, and to create that thread, we need a thread library which is denoted by thread library. So here many to many, that means in case of many to many model, the many to many model multiplex many number of user thread. These are the user thread into equal or smaller number of kernel thread. Here you can see that there are three users, 3 and 3, total 6 number of threads, user level thread, and it is multiplex into the 6 number of kernel thread, kernel level thread. Okay. So that is nothing, that is the many to many model. So this model provide the best accuracy and concurrency. obviously. Okay. Now coming to the many into one, you can see that many user level thread is mapping into the single kernel level thread, and all these thread are performed by the CPU. Okay, so here only one thread can access the kernel at a same at a some time. So here multiple threads are unable to run in parallel on multiprocessor. So this one is not efficient also. And one-to-one model, basically this would be discussed in earlier slide. However, in case of earlier one-to-one relationship, user level thread to the kernel level thread. That means one user level thread is mapped into the one kernel level thread only, and after that it will be executed by the respective CPU. But it is quite interesting to note that this model provides more concurrency than the many to one model, because it is dedicated by one thread. User level thread is dedicated to the one kernel space. That's why the concurrency is better than the earlier model. But best one is the many to many model. Many to many model. Okay. And the example of this one-to-one model are like Windows NT, Windows 2000. Those are the example of one-to-one model. And the latest all the operating system like the sorry, Windows 17 or are based on the many to many model. Okay. Now coming to the monitor, next topic, that is the monitor. Okay. We already know that semaphore are used for the process synchronization purpose, and it provide the mutual exclusion in the processes. Similarly, monitors also provide process synchronization, and it also provide the mutual exclusion in the process synchronization during the sharing of resources. Okay, but however, monitors and semaphore contains many difference. Okay, in semaphore basically nothing but a integer, and that denotes the different operation like wait signal operation. Okay, based on the value of that wait and signal operation are performed. Okay, and we can enter into the critical section. But here the monitors are basically a synchronization construct. It is not the variable, but it is construct, and these are created to overcome the problem caused by the semaphore, such as the timing error. Okay, so what is basically monitor? So monitor are abstract data types and contain shared data variable and procedure. So inside the monitor, basically it is thus a construct, a synchronization construct, and it is basically a abstract data type, and it contains the all the shared data like conditional variable, other independent variable, and all the process that can be executed one by one. The shared data variable cannot be directly accessed by a process. Okay, the shared data variable which is shared across the different process, that cannot be accessed by a process outside the monitor, and the procedure are required to allow a single process to access the shared data. That means only one single process can access the shared data at a certain amount of time. So that is the main characteristic of monitor. Now coming to the others definition of monitor. So in others word, monitor are defined as the construct of the programming language which helps to controlling the shared data access. And moreover, it can be also defined as like this way, that monitor is a module or package which it encapsulates shared data structure, procedure, and the synchronization between the concurrent procedure invocations. So that is the another definition of the process monitor. So we should remember that it is basically a synchronization tool that use a synchronization construct, and in between it there are shared variables, conditional variables, and all the process that can access all should be inside the monitor. Okay, so we can write that monitor are used for the process synchronization. With help of the programming language, we can use the monitor to achieve mutual exclusion among the process. Suppose example of monitors in case of Java, Java synchronization method use monitor like notify and wait construct. So in case of like semaphore, ready and signal, sorry, wait and signal. Here we will notify and wait operation. Now characteristic of monitor. Now inside the monitors we can only execute one process at a time. That should be maintained throughout the process, throughout the code, because this will provide the mutual exclusion. So inside the monitor, one we can only execute one process at the same time. Now monitor are the group of procedure and conditional variable that are merged together in a special type of module. You can next, whenever you see the syntax of the module, it will be clear to you that monitors contain the conditional variables and the set of the process that can access the shared variable, and they are merged together in a special type of module, and one by one the process will be executed. Okay. Now if the process is running outside the monitor, then it cannot access the monitor internal variable. It is very clear that whenever a process is running outside the monitor, it should not access the monitor internal variable, but a process can call the procedure from the monitor. Okay. And we can consider monitor as a high level of synchronization. And obviously monitor are derived to simplify the complexity of the synchronization problem, and moreover it makes the parallel programming easy, and if monitor are used, then there is less error prone as compared to the semaphore. In case of semaphore, it is more error prone, but monitor is more sophisticated. And this one is the syntax. Just I'm giving you the idea or concept of the monitor. Details, for the details purpose, you can consider your reference book. So this one is the syntax. So initially we define the monitor as monitor demo, and inside them there is variable, conditional variable, procedure p2. Okay, so p1 p2 all are defined one by one, and this one is the conditional variable. Based on that, procedure p1 and p2 are can be accessed. But it should remember, only one process can active at a monitor at a certain time, like procedure p1. If it is active, so procedure p2 cannot be active at the same time. So only one process inside the monitor can be executed at a certain at that time instant. So for other process that need to be accessed, the share variable in a monitor have to be line up. Whenever the p1 is completed and it is released, then the second process can access the shared variable. Okay, so that is the syntax of the monitor. Clear? So what you have studies in this class, basically you studies the context switching, which is nothing but a uh, process to switch between two process or two threads also, or two tasks also. But the speed of the context switching is so high that we can there is some kind of illusion that all the processes are executed parallelly, but it is true that only one process are executing at a certain amount, at a certain or at a particular time instant. So that is the context switch. Threads are nothing, can be considered as the lightweight process which has particular functionalities. Okay. And there are different kind of threads is possible, user level threads and kernel level threads, and based on those two threads, we also called as multi-threading model. And thread is very important for us to perform to increase the efficiency of the execution of particular process, because many tasks can be performed parallelly. So that is the importance of threads. And next one is the monitor. Monitor is also another kind of synchronization tools, but the difference between the semaphore and the monitor is that semaphore is based on the individual variable, but whereas monitor is based on the structure, synchronization structure that consists of variable, conditional variable, and the process that can access them. As you should remember, inside the monitor only one process would be active, and after the releasing of that process or after the completion of that process, next process will able to access the shared variable. Okay, so thank you. If you have any doubt, please post them. That's all.